Hello everyone, welcome back to session 6 of Statistics for Data Scientists. We have started our inferential statistics and this is the part 2 of the inferential statistics. In our previous session, we have covered three important topics: sampling distribution, central limit theorem, and the confidence interval. Right, those are the important topics we have already completed. In today's session, we are going to talk about the hypothesis testing. Now, see, this is very important topic for those who are into the field of analytics, though for those as well who are in research and development, and even for those who are into academics. Okay, now because see, whatever we used to claim, or we whenever we used to solve a problem statement, we have like whether it is predictive or some other which needs some proof of evidence, right? So one of the among different approaches and solution or steps, hypothesis testing is also one of the approach, right? Whatever claim we used to make, we have to follow a certain steps or process in order to prove that our claim is correct. Okay, we have to present the evidences. Now, testing hypothesis and drawing inferences about the population from the sample are the part of inferential statistics, right? So basically, hypothesis testing is divided into two terms: null hypothesis and the alternative hypothesis. Suppose I have a factory, okay, and which produces a bulb, and I'm claiming that our factory it produces 100 defective bulbs, okay, on an average every day, on an average, on a day, on a everyday basis, on an average. Now this is our claim. Now, so if I'm claiming this, I have to prove it. I have to provide an evidence that my claim is correct. Okay, because someone else might claim that no, you are lying. Okay, your company produces or your factory produces more than that. Okay, or some other person they may claim that no, your conclusion is wrong. Your factory it produces less defective bulbs, right? But for my part of claim, I have to provide an evidence. Now, basically, I can go for hypothesis testing. I can give a solution, and I can prove it. Okay, that my claim is correct, and this is the evidence. So, this hypothesis testing, it consists of two parts: the null hypothesis and the alternative hypothesis. In null hypothesis, we assume that the sample observations are purely by chance. It is okay. It is happening purely by chance. What does it mean? That if I'm like whatever I have claimed that 100 defective bulbs are produced on a daily basis. Now the null hypothesis says that it is just happening by chance. There is no specific reason. There is no specific condition or situation. Okay, by which it is just generating 100. It is just producing 100 defective bulbs. This is what the null hypothesis says that. But when we talk about the alternative hypothesis, it says that no. So the alternative hypothesis will support that the 100 defective bulbs are not just getting produced by a chance. Okay, there is a specific non-random situation. Okay, there is non-random situation. There is a specific reason why it is producing 100 defective bulbs on an average. Right. So the null hypothesis is being represented by H naught and alternative is by H1. Okay, and see, we assume that the sample observations in the case of alternative hypothesis, we assume that the sample observations are not by chance. Okay, they are affected by some non-random situation. Right. So hypothesis testing is done on different levels of confidence, and we make use of z-score to calculate the probability. Okay, to calculate the probability. Now, see, we cannot accept the null hypothesis. We have to reject it. We have to always reject it. Null hypothesis is the part of hypothesis testing which we have to disprove. Let us take an example of a. Let us take an example what I have just mentioned. Okay, or let us take an example of a pharmaceutical company. Okay, so basically the null hypothesis testing. So hypothesis testing is divided into two parts: the null null hypothesis and the alternative hypothesis. Hypothesis presented by H naught, presented by H1. And in our hypothesis testing, we have to consider both of them. Okay, now let us take an example. Let us take an example that in our country or in our city there is new pharmaceutical company. Okay, and they are going to launch a medicine. Okay, they are going to launch a medicine and they claim that it is going to reduce the BP by at least 10 mmHg. Let us let us name this pharmaceutical company as Pharma A. Pharma A. Okay, it is going to produce some medicine, or it is going to introduce some medicine which will reduce the BP by 10 mmHg. This is what company is claiming that. Okay, now if company is claiming that it is going to reduce the BP by 10 mmHg, they have to provide an evidence for their claim. Okay, now in order to evaluate, we have to find we have to find an evidence which should support their claim. Okay, now let us consider this step itself, this question itself, and we will see what are the steps that are involved in hypothesis testing. So we will try to solve this problem statement with the help of hypothesis testing. Now let us hypothesis hypothesis testing. Okay. Now, see the formulation, the first steps towards the hypothesis testing is step one. Okay. The first step in the hypothesis testing is the formulation of hypothesis. What is that? Formulation of hypothesis. What does it mean? I'll tell you. Formulation of hypothesis. Okay, so see the formulation of hypothesis. So both the hypothesis we have to consider, the null hypothesis and the alternative hypothesis. So the null hypothesis will say that the company is claiming that it is going to reduce the BP at least by 10 mmHg. Okay, so the null hypothesis will say no, it is not going to reduce the BP by 10 mmHg. 10 mmHg. It could be more than that. Okay, so the medicine, the formulation will be the medicine will not, it will not reduce the BP by 10 mmHg. It is not going to reduce by 10 mmHg. So the null hypothesis will be H naught. Okay, it will be, so it will be greater than 10 mmHg. This is the formulation of null hypothesis. Okay, we are representing it with H naught. Now the alternative hypothesis. Okay, alternative. Alternative will be H1, right? So the alternative, it is the if in the case of alternative, we will consider no, it will be less than 10 mm, 10 mmHg, right? 10 mmHg, because the company is claiming that it is going to reduce the BP at least by 10 mm hypothesis and the alternative hypothesis. Okay, for H naught it is greater than equal to 10 mmHg, and the alternative hypothesis says that it will be less than 10 mmHg. Now the step two. Okay, so in step two we have to choose the significance level. Step two. Step two. Choose significance level. Choose significance level, which is also denoted by alpha. Okay, now see, basically we used to for basically we always used to prefer the confidence interval of 95%, right? You know that basically we prefer 95% of confidence interval, because most of the data point, 95% of the data points are being covered, and even the standard deviation is just 2. Okay, we are not We are not going for the third standard deviation because there is more the distance among the data points are more. Okay, so the chances of error and the margin error in that case increases. Okay, so basically the z score in this case, the z score for 95% of not z score. Okay, so basically the significance level, yeah. So in this case, the significance level for confidence interval is 95%. The significance level is 0.05. Okay, this is step 2. Now in step 3, we used to collect data. Collect data in the sense, I'll tell you. Okay, now in this problem statement, as the company is claiming that it is going to reduce the BP at least by 10 mmHg. Okay, now we have to collect the sample data, right? Suppose we would have taken thousands of patients. Okay, we have given them the medicine to the high BP person. Okay, and we will calculate the average of different sample. We will take some 50 patients as a one sample, then 50 patient as second sample. We will calculate the average BP, right? In that way, we used to collect data. This is about, so in the step third, we are collecting the data, right? Or the sample. Okay. In step four is all about the statistics. Okay. Let's calculate the calculate test statistics. Okay, so basically we used to find the z score. Okay, we calculate the t test statistic, which measures the difference between the sample mean and the hypothesized population mean under the null hypothesis, right? It calculates the test statistic. How are we what are we going to calculate over here? Okay, basically we try to find the difference between the sample mean and the hypothesized population mean. Okay, so the z score in this case, z score value, okay, the z score value will be the sample mean by the hypothesized mean by standard deviation, I believe. Yeah, standard deviation and the number of data points. Okay, so in this case, this is our sample mean, sample mean, and see, this mu is our hypothesized mean, hypothesized, hypothesized mean of the population. We can also call it as population mean, and sigma is nothing but the standard deviation. Population is standard deviation of population, and this is the sample size. Okay, now see what we are doing. This is the sample, this is our population. We are trying to find the difference between these two, and then this sigma, it is the standard deviation among the population, and this is the number of, and this is the sample size. Okay, so we are correlating the values between the sample and the population and trying to find the z score. Right. So this will, in this case we are going to, this is how we are going to calculate the test statistic. Okay, this is the step 4. In step 5, we have to determine the critical region. Okay, it is about determine critical region. Okay, and in step 6 we have to make decision. We have to make decision based on the test statistics and the critical region. Okay, so this is all about the this is all about the different steps that are there in hypothesis testing. Okay, now once we make our decision, we used to draw a conclusion. right? Whatever this is the decision make, that will define the characteristics of the entire population, right? Or whatever, or like it will decide about, it will give the influences about our claim, right? Now see, uh, there are multiple approaches and multiple ways of testing. Okay, like we can, we just finish it over here. Or in case you want to see like what are the steps included, let me just reduce the size of it. Okay, so basically, so null hypothesis, alternative hypothesis, and then within hypothesis, formulation of hypothesis. Then step two include is choose the significance level. Step three, collect the data and sample. Step four is calculating the statistics, where we are trying to find the z-score. Step five is determining the critical region. Okay, and step six is the making decision. Okay, sorry, I just forgot to tell you about that determining the critical region. Now see, since the alternative hypothesis is one-sided in this case, how, I'll tell you. See, we have to find the direction from the problem statement. Okay, we have to find the direction. Now in this case, the direction is that the company is claiming that it is going to reduce the BP at least by 10 mmHg, at least by 10 mmHg. What does it mean? What does it means that? It means that the mu value is less than 10, at least by 10 mmHg. So it is showing that it is just in one direction. Okay, in case it would have said that it can reduce the BP by 10 m by minimum by at least 10 mmHg, or it can reduce even more than that. In that case, what would be the value? It could be less than 10, and it could even be, sorry, it could, and even it could be more than. In that case it will be two-sided, but in this case it is just one-sided, right? And this is the direction that and this plays an important role, finding a direction from your problem statement, right? There is no specific way of finding the direction. You have to find it from the problem statement itself. Okay, because we have to find like critical region, we need to find it. Okay, else we may proceed in another direction of our statistics. Okay, and after that we used to make decision whether we have to reject the null hypothesis, or like we don't have enough evidence to reject the null hypothesis. Okay, and then we can draw a conclusion. Okay, since the test statistics falls in the critical region, we reject the null hypothesis. Right, now the hypothesis testing, within hypothesis testing we have multiple. Let me just, okay, no, okay, so just a moment. Hypothesis testing and regression analysis. So as I said that we have multiple approaches and solutions, right? And we can follow any of them. Okay, for if when we talk about null hypothesis, the different approaches are, we can implement Z test, we can go ahead with F test. Okay, we can, and we have again T test, we have ANOVA test, we have ANOVA test, and then again we have Wilcox Wilcoxon signed rank test. Okay, and then one more test is man whiteley. Okay, man whiteley rank test. And man whiteley unit test. Okay, these are the different tests within hypothesis testing. Now within regression, we have linear regression, the most common one. Okay, linear regression. We used to we try to find out the best fit line. Then we have nominal regression. We have nominal regression. We have logistic regression, and then we have ordinal regression. Okay. Now see, all these different tests within hypothesis testing and even in the regression analytics, it is not like we cannot fit all the tests like it is not going to be applicable for all the sample problem. Okay, there are like a it depends on different cases. It varies with even attributes. Okay, different sample, the sample size. Okay, so that's what it is not applicable under all the circumstances. These different tests are implemented in different situation and different cases. Okay, now basically, so our next topic is the Z test, right? I'll tell you about Z test. Now let me see what are the different things we have. Okay, so I already spoken about the basics of hypothesis testing. Different step. What are these steps? The number one is the formulation of hypothesis. Number two is finding the choosing the significance level. Step three is collecting the data. Step four is calculating the test statistics. Step five is determining the critical region. Okay, like you can see, formulate hypothesis. Choose the. My brain is not going to work. Yes, it will. Okay. So step one is formulation of hypothesis. Step two is choose the test statistics. Okay. Step three is the specify significance level. Okay, that I have mentioned in step two. Okay. So significance level, we have to decide what is the significance level that we have to consider, whether it is 95% of say, confidence interval, or we can choose more than that. Okay. Now the collecting data, calculate the test statistics, calculate p-value. We have to make decision and then we have to draw the conclusion. Okay, the type 1 error and type 2 error, I will discuss it in detail. Okay, when we will deal with a particular solution, at that place I'll discuss it. So okay, so in this case you can see we have an example: new teaching method aimed at improving the student's math score. We will follow each step of hypothesis testing. Now the problem statement is that a new teaching method has been implemented, okay, to improve the students math score. Right. Now, the step one is formulation of hypothesis. Now, the null hypothesis will says that no, it is not going to improve the math score. With the help of this new method, there won't be any effect on the math score. That is what this is null hypothesis. The new teaching method has no effect on students' math score. So here the mean score, the mu value is zero. Now the alternative hypothesis will says that no, it is going to improve the math score. So we are going to the mu value is greater than zero. Now the step two is choosing the test statistic. Since we are comparing the mean of math score and a math score of two groups, right? Before and after the implementation. So we will use the pair test as our test statistic. See, why test has been used. Even there are some other reasons I'll tell you. See, when the sample size is very small, it's not very small. It's when it is a small. In that cases, you can just keep it in mind. When the sample size is small, in that cases, generally we prefer the t-test. Okay, yeah. So in that case, we have preferred the t-test, and after that, we have to specify the significance level. We have chosen the significance level as 0.05. I mentioned that basically in most of the cases we prefer the 95% of the confidence interval. So in this case as well, we have taken the, so the significance level for confidence interval 95% is 0.05. So we have taken 0.05. Now in after that, collection of the data, okay, and then we have to calculate the test statistics. So the t-test, so the t-test formula is the mean value x now x. Okay, so in this case you can see that this is the mean value and this is the hypothesized population mean. Okay, and then the standard deviation by the sample size. Okay, so after that we are just calculating the p-value which is associated with the test result statistics. Okay, and that is the, so we can get the value of we can get the p-value from the t distribution table, and based on that we can make decision and we can draw a conclusion. So this is the basic steps. We will see number of examples in the upcoming session, but right now we are just giving an exposure like what are the steps which are there in this. Okay, so this is all about the hypothesis testing. So z test, now basically z test, it is also a kind of a statistical hypothesis, okay, which is used to compare the sample mean to a known population mean. Okay, so yes, when the mean of the sample as well as mean of the population is known, in that case we used to implement the z test. Okay, so basically we used to compare the sample mean with that of the population mean. I'll give you an example. No, see, basically there are two types of Z test. One is one sample Z test and one is two sample Z test. So in one sample test Z test, we compare the sample mean with that of population mean, and in case of two sample Z test, we compare the sample mean of two different sample with respect to its with respect to each other, right? So in the one sample z test you can see that we this x bar, this is the sample mean, and mu naught, it is the population mean, right? And in this case, in the case of two sample z test, x bar x1 minus x1 bar minus x2 bar, this is the sample mean of sample 1 and sample mean of sample 2, right? So we are finding a difference among the two different samples of a population when the sample size is greater than or equal to 30 and the population standard deviation is known. Just keep a note. Okay, let me just write it. Okay, z test. Okay, so it is based on the standard normal distribution and is commonly used for comparing the population mean or proportions or variance. Okay, so I have already told you like under what situation the basically in the one test, one sample z test and two sample z test. In one sample z test, we are comparing the mean with the population. In two sample z test, we are comparing the means among two different samples. Okay, this is how we are calculating the this is how we are calculating the sample test, right? The z test. Now let us take an example. So I think okay, Z test is a strategy to determine whether two population means are different or to compare one mean to a hypothesized value when the variants are known and the sample size is large. Okay, so let us take an example. In this case, a sample of 400 students were tested on 50-meter dash. Okay, samples. What is the sample size? 400 students. It is tested on a 50-meter dash. The mean performance and the standard deviation were 7.2 second and 0.15. Okay, so the mean value is 7.2 and the standard deviation is 0.15, and the standard deviation is this. Okay, so respectively. Okay, is the sample from the large population of a mean performance? Okay, is the sample from a large population of a mean performance 7.232 second and the standard deviation is okay. Okay, so basically, we need to claim that the mean of the sample is same as the sample population, as that of population. Okay, so in this case, let me just let us know. Okay, so will Okay, so okay, let us take this example. A sample of 400 students, 400 students were tested on a 50-meter dash. Their mean performance and the standard deviation were 7.2 second and 0.15 second respectively. Is the sample from a large population of a mean? Okay, performance 7.32 second and standard deviation 0.5 second. Okay, so basically what we need to claim that the mean of a sample is same as that of population. Okay, that is what it is claiming. Is the sample from a large population of mean with a performance of 7.32 second and standard deviation as 0.15 second. So we need to claim that the mean of the sample is same as that of population. Okay, so so basically we need to claim what we need to claim to claim that mean of sample is same as population. Now, basically the number step number one. Okay, in step one, what we used to do, we for the hypothesis, formulation of hypothesis, right? So the null hypothesis in this case will be okay. What is the so uh, basically the mean value that we are talking about. Okay, so in this case, the mean value, just a moment. So a sample of 400 students, okay, the mean performance and the standard. So the mean value is 7.2, right? So in this case, the mean value is 7.32, right? And the alternate value for okay, the alternate in the alternate hypothesis, okay, we'll say that no, it is not going to be same. Okay, that is what we are going to claim over here is that. Okay, so basically what we are claiming that the mean of the sample is same as that of population. Okay, in that case the null hypothesis will be like it will say there is no difference. Okay, it is same. Okay, but the alternative hypothesis we are claiming that no, it is not same, it is different. Right. Now the step number two is level of significance. Step two. Step number two. Okay, we have to choose the significance level. Okay, significance level. So basically, we are considering 0.05. The like because the confidence interval we are considering over here is 95%. In step three, we have to we have to find the test statistic. We already have the data. Okay, basically the step three is about collecting the data, but let's directly calculate the test statistics. Okay, we will try to calculate the test statistics. Now we are trying to calculate the z score. So the formula was x bar minus mu by sigma and then the the sample size, right? In this case x bar is sample mean. I hope you remember. Mu is the population mean, right? And the sigma is as I remember that it is the standard deviation of population, and this is n is what is that? N is sample size, right? So if that is the case, so the z score will be okay. So sample mean we have 7.20, okay, and then the 7 point just a moment. Let me okay. It is yeah 7.2 and then we have 7.32. Okay. Yeah, 7.20 and then 7.32 and then the standard deviation we have 0.15, right? 0.15 by number of the sample size is 400, right? So this will be minus 1.2 by 0.5, 0.15 into this 400, so it will become 20, right? So we will get, this is the test score. Now, see, when we say that, now the next step is the uh, selection of critical region, right? Yeah. So the null hypothesis. Okay. So basically, see, in this case, okay, this is the this is our rejection area. This is the area of rejection. Okay, and this is the acceptance region. This will be our acceptance region. This will be our rejection region. In this case, so this will be 1.96 and 1.96. Okay, see, because why it is 1.96? For okay, when we take the absolute value of C, it will be 16, right? And from the Z score table, okay, from the table Z score table, from Z score table for values 16, it will be 1.96. Okay, the value is 1.96. Okay, no, just a moment. No, the value of Z score required for, no, the value of, just a moment, the value of, no, the value of Z score for significance level 0.05. Okay, it is 1.96. It is 1.96. Now in this case, since we have the Z value as 16, okay, therefore therefore absolute Z is greater than 1.96. Okay, hence in this case, it's not done, is rejected. Okay, it is rejected at is rejected at 0.05 level of significance. And hence we conclude that the data do not provide enough evidence to support the null hypothesis. Okay, it do not provide enough evidence to support this null hypothesis. So in our next session, we will talk about the t test and f test. Okay, so the test. So this is the region of rejection. Okay, the highlighted area is the region of rejection. This is the acceptance region. Okay, fine. Thank you. See you in next session. And please do subscribe to our channel as we are working for you. Thank you. Okay, it was 7.2 second and 0.15 second was the standard deviation. Okay. Now the question was: is the sample from the large population of the mean performance 1.32 second and standard deviation 0.15 second? So basically, they are claiming that whether the sample is from the same population or not. Okay, so basically the first steps towards the hypothesis testing is the formulation of hypothesis, right? We have to formulate the hypothesis. So in the step one, we have to claim that the mean of the sample is same as that of population, right? So basically in the null hypothesis we are considering that there is no difference between the mean of the sample and the population, so it is 7.32. But alternative hypothesis, we are just we are considering that it is no, the mean of both population and sample are not same, right? Now, in the step two, or in the step two of hypothesis testing, we have to choose the significance level. Okay, so for confidence intervals 95%, the alpha value is 0.05. Right, this is the most preferred significance value that we used to consider. In step third, we have to find the test statistic. Before that, we used to find the data, we used to collect the data, but we already have the sample size as 400. Okay, we have the sample size as 400. So what we did that, so like this is the, here is the difference of the difference between the sample mean and the population mean by the standard deviation and the population size sample size. Okay, see, so we got a z score value as 16. The absolute value of z score is 16. Now in the step 4, we have to find the critical region, right? So we have to find the critical region, because we have to like, yeah. So basically, with on top of this critical region itself, we will draw a conclusion whether we have to reject the hypothesis or we have to accept the hypothesis. Okay, whether it is within the acceptance region or it is within the rejection region. Okay, so after calculating the score, we are getting the absolute value of z as 16, and the value of z which is required for significance level from the z score table, that is 0. Okay, so basically the value of z z score required for significance level. Yeah, so when, like, in case if you will see it from the table, okay, for the significance level 0.05, z score value is 1.96. Okay, so like in case if I have to draw the table, draw the distribution. Okay, so this is the 1.96. Okay, 1.96, and this is the rejection region. Okay, which I was, and this is our acceptance region. Okay, so basically, so now the z value is greater than 1.96. Okay, that means that we are not in between the, we do not fall in the rejection region, since it is a one tailed coin. Okay, it is a one sample coin. So it is 1.96 we are considering, plus 1.96. So and we are greater than 1.96. So we reject the null hypothesis. Okay, that means that the sample size and the population mean and the sample mean are not same. Okay, so we conclude that we do not provide, like, we don't have enough evidence to support the null hypothesis. Okay, so we reject it. So this was all about the Z test.